Prove that if n is any non-negative integer whose decimal representation ends in 5, then 5 divides n. So we're proving a universally quantified statement. So let's start this by instantiating the variable that's being quantified as an arbitrary instantiation. So let n be a non-negative integer whose decimal representation ends in a 5. Now we can write n using a certain amount of digits. We don't know how many digits we need, but let's just say we use k digits. So each of these here would be my digits, all the way down to A3, A2, and A1. Now keep in mind that this is not multiplication. These are all digits in the number n. The important thing here is that we know that A1 is 5, since the number n ends in a 5 when we write out the decimal representation. Now we can rewrite this number as 5, which is the ones place, plus A2 factors of the tens place, which is 10, plus A3 factors of the hundreds place, which is 10 squared, all the way up to ak minus 1 times 10 to the k minus 2, and then plus the leftmost digit times 10 to the k minus 1. So this is another way we can write this number, and from here we can clearly factor out a 5. This is 5 times 1 plus a2 times, instead of 10, we would write this as 2, since we pulled out a factor of 5. For the next term, when we pull out a factor of 5, we would have a factor of 2 remaining and another factor of 10. For ak minus 1, we would have a factor of 2, and we would only have k minus 3 factors of 10. And for ak, we would have a factor of 2 and k minus 2 factors of 10. This number here is an integer, since integers are closed under addition and multiplication. We'll call this integer m. So this means that n equals 5 times some integer m, which means that by definition, 5 divides n. Thanks everyone, and I'll see you in the next video.